Hello friends, in the previous video we have discussed about magnetic field due to straight current carrying conductor. Now in this present lecture we are going to discuss about magnetic field direction due to the current carrying circular loop and current carrying solenoid. So how exactly we can determine the magnetic field direction in the case of a circular coil? We shall see now through an activity. Magnetic field due to current carrying circular loop. So how exactly a circular coil can reduce magnetic field, we shall see right now. So let us consider a particular plank, a table kind of structure, such that in that we need to make two holes. Which can ensure us to pass a wire through them and make a coil. So in the previous lecture I have discussed about the gauge of the wire. It must be 24 gauge in order to support a lesser battery of 9 to 12 volts battery. If not, if the gauge which we use in the household circuits will have to be connected with higher voltage battery. So we have to reduce the thickness of the wire, so we are going for 24 gauge instead of 12 to 14 gauge. So now this wire has to be taken from the bottom of the plank and ensure that it is passed like this, and it is taken out from the hole, and again it is passed to the other hole which we made in the plank. And this wire has to be made 4 to 5 turns to ensure that it has a standard coil shape. And after reaching this particular point, from the bottom of the plank or table, we need to connect these two ends of the wire or a circular loop to a battery and ensure that there is a switch in the loop. Now it is a positive terminal of the battery, this is negative terminal of the battery. The current starts flowing from positive terminal to negative terminal when you switch on the battery. This would be the direction of the electric current when you switch on the battery. And now what exactly we need to do is, we have to ensure that a magnetic compass is placed. Magnetic compass must be placed upon the circular current carrying loop. Upon this, let the diagram be like this, then only you can understand that it is raising above the diagram. So now the circular current carrying loop is there like this, and upon this plank you need to place a compass. Upon this plank you need to place a compass which will show you the north and south directions of the earth. So now, as we have discussed previously, when a current is passing through a conductor, if a compass is placed nearby it, it changes its direction because of the magnetic field produced by the current carrying conductor. The same thing happens in the case of this circular current carrying loop. What exactly happens is, when you switch on this circuit, the current starts flowing in the coil, which in turn produces the magnetic field, and there causes a deflection in this magnetic compass. Then you need to ensure that two dots are kept on the surface of the plank, showing the north and south directions, and again you have to remove this particular compass from that point, and you need to place it other end of the dot, and it will show you the other direction like this. Similarly, again you place the compass in other end of the dot like this. It starts making a circular loop around this. It starts making a circular loop in this direction like this. It starts making its own directions. These lines on joining the dots which are made by the compass, you can see the direction of the magnetic field. So always we cannot perform this particular activity to know the direction of the magnetic field. So there is a specific rule which we can do it with the right hand. Previously in the case of straight current carrying conductor, we have used our right hand to know the direction of the magnetic field. Similarly, even here the magnetic field, to know the magnetic field direction, we can apply a simple rule with our right hand. It's quite easy. In that case, we have put thumb in the direction of the magnetic field, but here in the case of circular loop, we will use our fingers to curl in the direction of the electric current. Here you see the current carrying direction is in clockwise direction. It is in clockwise direction. It is similar to the clock's direction, the minute's hand which move in the clock, similar to that direction. That is why I am calling it as clockwise direction. You curl your fingers. The remaining fingers other than thumb must be placed, curled in the direction of the current, such that your thumb will show you the direction of the magnetic field. Here the magnetic field starts rotating, getting into the loop like this. It will be into the loop that is indicated with an X mark B. In the previous lecture we have discussed that X mark indicates, the into mark indicates the direction into the plane. To make you understand this particular direction, I am going to use a circular loop. Which will ensure you to understand how to determine the directions of the magnetic field. So I am making a circular loop like this with a wire. So to make you understand how the right hand thumb rule works, I am going to use this circular loop. I have made a circular loop. Now you try to understand. Just a minute. So you can see this is the current carrying loop. This is the current carrying loop which has two ends like this. Let us suppose these are the two ends of this current carrying loop. I will make it proper. This is a circular loop which has two ends to it, which you can designate, which you differentiate between these two ends. Let us suppose this end is negative terminal and this end is positive terminal. Now you will ensure that these two ends are connected to the battery. Now the current starts flowing. If this is connected to the positive end, the current starts flowing from positive terminal to the negative terminal. Then the direction of the electric current is in clockwise direction. If you see, it's the clockwise direction. Now ensure that your fingers will be in the current direction, and your thumb will show you the magnetic field direction. The magnetic field is into the plane. The magnetic field is going into the coil like this. So the curled fingers will show you the electric current direction and the thumb will show you the magnetic field direction. If we reverse the direction, means this is connected to the positive terminal and this is connected to the negative terminal, then the current direction would be anti-clockwise. Even then you have to use your right hand to ensure the direction of the magnetic field. It is very simple. You take your fingers and curl in the direction of the electric current and thumb will show you the magnetic field direction. So always remember, the magnetic field lines would be circular in shape, ensuring that the magnetic field goes in this way and it comes back and it rejoins, it makes a circular loop like this. A magnetic field line will go into the plane and it will come out and make a circular loop like this. Always remember that the field lines would be a closed loop. So in the clockwise direction, the magnetic field will be into the plane, it goes into the plane, the magnetic field line goes into the plane and it comes back and makes a circular loop around this loop. The magnetic field lines will exist as circles around the loop like this. Let me show you the proper diagram here. If you consider this to a circular loop which is carrying electric current in the clockwise direction, then you try to understand the magnetic field lines would go and encircles this loop. B direction would be like this. It will go into the plane like this. Here also they would go into the plane and they will come back and complete the circle. Similarly, the magnetic field lines would be encircling the loop. They will be encircling the loop like this, which are moving into the plane. See, even in your textbook you can find this kind of problems. They may ask a question like this, they may give a circular loop upon your paper and they may ask, if the current is going in a clockwise direction like this, if the clockwise direction, then you place your fingers in the clockwise direction and your thumb will show you that the magnetic field is going into the paper. If the current carrying direction is given in an anti-clockwise direction, you curl your fingers in the anti-clockwise direction, your thumb will show you that the magnetic field is coming out of the plane. So these are the two ways you can determine the magnetic field direction in the case of circular current carrying loop. Next we are going to understand how the solenoid would be. The magnetic field lines in the solenoid, the magnetic field direction in the case of solenoid current carrying conductor. So till till now we have discussed two cases. One is circular current carrying loop, and it is first one is straight current carrying conductor, next one is circular current carrying conductor. Now we are going to discuss about solenoid. So what do you mean by solenoid? Solenoid is nothing but a spring kind of shape. You can see a shape which is of like this is called as solenoid. So how can we make this kind of solenoid? Making a circular loop is very easy. Making a straight wire is very easy. But how are we going to make this solenoid to observe the magnetic field lines around it? We have used magnetic compass in these two cases to understand the magnetic field lines. In the same way, you can understand the magnetic field lines in the case of solenoid, but in a bit different way. We use iron filings in this case to know the direction of the magnetic field, how the magnetic field lines would be arranged around this solenoid. For this, we have a simple activity. Just take a plank again in a similar way. You need to take a plank and stick a white chart to this. Such that whatever is arranged upon this chart would be visible. Stick a white chart upon this particular plank, wooden plank which you are considering, and make equidistant holes. These kind of holes must be made. Equidistant holes must be made in the plank to make solenoid. So how exactly are we going to do the solenoid? By placing holes similar to the circular loop, but you have to take this wire from beneath the table, and you have to pull it out from this hole and ensure that it is passing through other hole, and you take it out from that hole. You have to pass through one hole. You have to make holes in the plank like this. You have to make holes in the planks, and what you do, you take a wire from beneath, and you need to ensure that it is passing through one hole, and again you take it from one hole and pass it through the opposite hole, and take it from bottom and pass it to the beside row hole, and again you pass it to the opposite hole. Like that you can make a solenoid, perfect solenoid shaped one. Take it from this and ensure that this is passed through the opposite hole, and again you take it to the opposite hole. And it is pulled out of the setup to connect it to the battery like this. Terminal and negative terminal. Now you can see perfect solenoid shape, which is of like spring only. The current direction would be so, because we have connected this particular side of the end of the wire to the positive terminal and this to the negative terminal. So the current direction would be like this. Now what you have to do is you have to ensure there will be iron fillings. Iron fillings are particles which can be attracted by the magnetic field, and they arrange themselves in the shape of the magnetic lines of force. You drop iron filings upon the sheet which you have stick to the blank, and switch on the circuit. Switch on the circuit with the help of a key. If the key is not switched on, you just ensure that the switch is on. Now the current starts flowing like this, and iron fillings are spreaded over here, and just tapped upon the blank, such that these iron filings will start arranging themselves in the shape of field lines like this. You can see the iron filings would be arranged like this, which looks much similar to the lines of force. Even In the case of bar magnet, you can see this kind of arrangement. If you take a bar magnet, if you consider a bar magnet, North Pole and South Pole, the magnetic, if you drop iron filings would arrange themselves in the shape similar to the setup, similar to the iron filings arrangement which are around the solenoid. You can observe nearby this bar magnet even. So here, to ensure the north and south poles of the solenoid, there is a simple technique which was just simple technique. You arrange your fingers in the direction of the electric current, and your thumb will show you the north direction. Your thumb will show you the north direction, and the opposite end would show you the south direction. These two north and south poles would be similar to the north and south poles of bar magnet. So when you curl your fingers in the direction of the electric current, the thumb will show you the north direction of the magnet which was created by passing electric current through this circuit, and south pole respectively. So yeah, these field lines are closed field lines. Even these field lines are closed field lines. I told you, magnetic field lines are always arranged, in the closed loops. Here, in the outside, the lines of force would be passing from north pole to south pole, but within the solenoid, the lines of force would be running from south pole to north pole, south pole to north pole, but outside they will be running from north pole to south pole. Within the solenoid, it will be from south pole to north pole. So these are the two cases which you need to understand. The magnetic field lines would be similar to the bar magnet in the case of solenoid. So I hope you have understood how to determine the directions of the magnetic field lines in the case of circular current carrying loop and the solenoid. That's all, friends.